to the CloudSocket SLA engine webinar. My name is Roman Sosa, software engineer from the Advanced Cloud Lab of Atos Research and Innovation. Before we start, some technical details about the webinar. All microphones are muted, and if you have any question during the talk or afterwards, just type it in the chat screen. I will answer them at the end of the webinar. The agenda for today is the following. We will start with an introduction of the CloudSocket project. Then we will talk about service level agreements. After that, I will introduce the SLA engine, a demo of the SLA engine in CloudSocket, and to finalize the summary of the webinar and a slot for questions and answers. So let's start with the introduction to the CloudSocket project. This is the website of CloudSocket, where you can get all the details about the project. One moment, please. Okay. Here you can read about the project vision, the detailed information about the CloudSocket platform. Anyway, I will introduce here the project in order to get the necessary context for the webinar. Well, the companies want to use business processes in order to increase productivity, to automatize processes, etc. So the challenge here is how we can bring this business process to the cloud. This is not a simple task. We have different approaches. We have different functionalities. So what CloudSocket provides is this smart connection between the business requirements and how we can move it to the cloud in order to take advantage of it. The main target group of CloudSocket is the group of small, medium enterprises, which, for example, have not defined yet their business processes or are looking for some predefined business processes. And the target group is the BPM experts, or so-called brokers, which will define business processes that will be offered to SMEs by means of the CloudSocket platform. CloudSocket has covered the business process lifecycle, but adapted to this cloud approach. Here you can see the CloudSocket architecture. It's not the focus of this webinar to explain the architecture in detail, but I use it to explain the different phases covered in CloudSocket. First of all, we have a design phase managed by the BPaaS design environment. It is responsible for creating the business process at a high level to understand what are the requirements, what are the necessities of the customer in order to provide the business process. The result is the BPaaS design package, okay, which contains the business process and workflows that will be deployed on the cloud. To define how to deploy this business process on the cloud, we enter the allocation phase managed by the BPaaS allocation environment. Here we indicate the resources where we want to deploy the business processes and related software components. For example, here the broker may decide to deploy the business process on Amazon or on a PaaS provider on an own cloud and they own. They define also prices for the service, the definition of the service level agreement. The the definition of this service level agreement is related to the SLA engine, and I will explain later. It is enough to say for the moment that in this tool, in the allocation environment, the business process designer can specify service level objectives that the execution of the service should fulfill. For example, that the response time of a request must be always below 1 second. The output of the allocation phase is called a BPaaS bundle, and it contains the output of the design phase, plus the information added in the allocation, resources, SLA, pricing, etc. Once the BPaaS bundle has been defined, we must publish it somewhere. We have included a marketplace where companies can buy the service offered via BPaaS bundle. This marketplace is in the BPaaS execution environment, which is responsible for the deployment on cloud and execution of this BPaaS bundle. And finally, to close the feedback, we have the BPaaS evaluation environment, which is responsible for analyzing all the data collected during the deployment and execution of the BPaaS bundle, and to provide the feedback to the brokers in order to improve the business processes or the business process, or identify new business processes that could be included in the marketplace. Okay, let's talk about SLAs now. SLA stands for Service Level Agreement. I am showing here the definition from Wikipedia. It is a part of a contract between a service and a provider. And in this SLA, the provider guarantees a quality of service to the customer. The SLAs are very used in the world of cloud providers. For example, we have, I can show here the SLA offered by Amazon Web Services. Rackspace offers this SLA. It's a document where you can check the quality of service that Rackspace offers. In these two examples, the warranty is only applied to the availability of the service. They say that they will provide a minimum service uptime for a month, and if they are not able to comply with it, credits will be offered to the customer. This is our example. Well, our cloud providers do not even have a formal commitment to warranty the service quality, and they just offer a promise. CloudSocket gives more control to define richer SLAs, which allow brokers to stand out for other providers, and also allow users to be more confident about the quality of service the customer is contracting. There have been proposed several specifications about SLAs. Here you can see a list of them. In this webinar, we will focus in WB's agreement, since the SLA engine is based on this specification. There are two web services agreement specifications. The first one is the main specification, web services agreement. That is, this was written by Open Grid Forum. You can get the specification in this URL, and it basically defines on one hand, an XML structure for the representation of templates and agreements. That these are the two main entities that the WS agreement defines. An agreement is the specification of the quality of service between a service and between a service provider and a customer. And a template is just a document that can be used as a template to create an agreement, and it's not tied to a customer. And on the other hand, the specification defines a web services interface for handling mainly the entities, the templates and agreements of the specification, and how to deal with the service offered by the provider. It also it is considered as a one-shot negotiation because there is not a real negotiation between the customer and the provider to get an agreement. And to overcome this one-shot negotiation, Open Grid Forum defined another specification that is called WS Agreement Negotiation. That is, and you can get the specification at this URL. The structure of an agreement in WS agreement is composed of these main blocks. We have a context where the information about what are the parties that are participating in the agreement are defined. I mean, the customer, at least the customer and the provider, the lifetime of the agreement, and the reference of the template if this agreement is based on a template. Then we have a main building block of terms where we can, and I will highlight here the service description terms where the functional description of the service is described, and the warranty terms that define what guarantees, warranties this agreement will assess, and which penalties are applied in case of the warranty is violated. This is an example of an agreement. It is not complete, and just simply the main blocks of the previous slide are here expressed in an XML format. Now we will talk about the SLA engine. It is a component developed inside Atos Research and Innovation that has been adapted to the CloudSocket platform. It comprises two main components, SLA core, that is responsible for storing the entities of the SLA entities, responsible for the evaluation of the agreements, and it offers a REST facade for interacting with the documents. And it also the other component is the SLA dashboard that is simply a user interface where the user can the customer and the providers can check the status of the agreements. The requirements of the SLA engine is MySQL database and external monitoring. And This SLA engine is WS agreement compliant in the specification of the SLA documents. The features of the SLA engine are these. WS agreement that specifies XML for the SLA documents. The SLA engine additionally allows specifying these documents in JSON as a simple translation from XML. It uses one-shot negotiation. If more complex negotiation is needed, then this whole process has to be provided externally. It provides uses a REST interface instead of the web services interface specified in the WS agreement. It supports evaluation of SLOs and associated business cases, associated business values in case the SLOs are violated. And as I said before, it needs an external monitoring service. The SLA engine is prepared to adapt to different monitorings. For example, it can use monitorings that where you need to subscribe in order to get the metric data, or you have to make an active polling, and even you can also use smart monitoring. And understanding here, smart monitoring is monitoring that is able to evaluate quality of service. It is able to send notifications of violations and penalties to interested observers, and it is configurable and extendable. There is, I forgot to say something here. The most of these terms, for example, the description of the service level objectives and the penalties are expressed as domain level expressions. So the WS agreement does not actually define them, but it is left to the implementer to define an expression for it. So it is obvious that the SLA engine has to be configurable because several elements of WS agreement are defined as domain expressions, and additionally to this, the SLA engine uses the concepts from the WS agreement, but it could use another structure other than the WS agreement. So we could use another data model. This is the architecture of the SLA engine. There are two main blocks, the SLA core and the SLA dashboard. We can see here the REST service that is the point to the outside. I have here the assessment component that is responsible for the evaluation, and some external components that will interface with the SLA engine. For example, here we have an SLA contract generator that this is not needed, but this REST service needs to be fed with a agreements and templates already in the release agreement. So you need an external component that builds these documents, these templates and agreements in this XML format of the specification. So this could be the component that generates these documents. And the monitoring service, where that, and as said before, I can consider here two monitorings. One that simply provides raw metrics or aggregated metrics to the core. So here we will evaluate the warranty terms, the QoS, and if there is a violation, it is communicated to this subcomponent that evaluates if there is a penalty or not. And in case of producing a violation of a penalty, then it is communicated to an external accounting component, or violations can be also communicated to a self-adaptation component. So the SLA is not is tried to not be violated again. So let's see how we have adapted the SLA engine into CloudSocket. If you remember, we have two main groups, two main target groups in CloudSocket. We have the SMEs, and we have the brokers, the BPM experts. The brokers offers the service of the BPaaS bundle to the SMEs. So the brokers are the service providers, and the SMEs are the customers. So in the CloudSocket SLAs, the provider is the broker, and the customer is the SME. And what can be measured, what can be guaranteed for to the customer is, for example, execution of the BPaaS bundle. Something response times, for example, response time of the software components that are being deployed in the cloud, or even the performance of the business process itself. For example, we can have a business process that sends mails to a huge list of persons, and one SLO to fulfill is that the 95% of the mails are sent correctly. So what we have here is basically the same diagram components of the previous slide, but we have included the web service agreement generator inside the core. The allocation, if you remember, the allocation environment is where the BPaaS designer defines what the service level objectives that the BPaaS bundle will contain. So the allocation passes the information to this generator. The template, the document, the WS agreement is generated, and it passes to the rest of the SLA core. And then we have the monitoring of CloudSocket, which is Colosseum. We need an adapter to adapt the metrics from received from the monitoring to the internal presentation in the SLA core that is evaluated, and any violations and penalties are communicated to the accounting component of the broker. So any violation, any penalty produced in the service offered by the broker is reflected in the bill, in the invoice that the broker will emit to the customer at the end of the billing period. Okay. Here are in detail the interactions of the SLA engine with the rest of the components of the CloudSocket platform. As I said, we have the allocation component that sends the information to the generator to create a template. This template is stored in the service and is returned to the location, so it can be included in the BPaaS bundle. The BPaaS bundle is published in the marketplace, and then once it's published, there will be a customer that buys the bundle. At some time, the cloud provider engine will communicate to the SLA service that the bundle is deployed. The SLA service have to subscribe to the monitoring engine, and then in execution, the monitoring engine will send the data to the SLA service, and the metrics, the data will be evaluated. So let's move to the demo now. What we are going to do is that we will search a bundle in the marketplace. We will check the SLA of this BPaaS bundle. We will buy it, and we will finally check the assessment of the SLA once the BPaaS bundle has been deployed. No. Okay, this is the marketplace of CloudSocket. What we're going to do is to look for this BPaaS bundle. Okay, data first. This is a send invoice. This is a BPaaS bundle, the business process to send invoices. And the SLA is this. We have two SLOs. One is that the RAM usage of the software component has to be always below 98%. And the other one is that the response time have to be always less than 250 milliseconds. And any time the SLO is violated, it will occur. This violation will be raised. There will be a discount of 10 euros for the current month. So let's buy it. Then we go to the cart. We will check out, and then I will do the payment. Since the deployment takes some time, what I decided to do is to have a bundle already deployed, so we can move faster in the demo. And I'm going to log in into the SLA dashboard, and we are interested in this SLA of this bundle. It has already violated because it was deployed yesterday, and there was some problems with the virtual machine where it was deployed. Let's have more information about the agreement. Right now, these are the metrics that we are receiving about the RAM usage and about the response time of the service. We can see that there have been 16 violations up to now, 8 yesterday, 8 today, and these are the penalties that have been applied up to the moment. What I'm going to do now is to stress the virtual machine so we can see the violations occur in a few moments. Let's wait 1 minute or so. Okay, here we can see that the response time has been increased, even the RAM usage. The increase in the RAM usage was not expected. Oops. Okay. The violations have been are being occurring. We have 2 new violations. We have 2 new penalties for each of these violations. We can check here the the values of these new violations, they are pretty much higher than the previous violations. For example, raised 2 hours ago. And I wanted to make a summary of what we have done here in the demo. As an SME, as a customer, I entered the marketplace. I bought a BPaaS bundle. The BPaaS bundle was deployed, and then as the customer, I was checking that the BPaaS bundle is behaving as expected in the SLA. It was violated, so I will get some discount in the invoice I receive at the end of the billing period. And to return to the presentation, this is the summary of what we have seen today. We have shown that there's a component, the SLA engine, that enables the assessment of the SLA of BPaaS bundles by the generation of WS agreement documents, the assessment of service level objectives and associated penalties, and it provides a user interface to allow brokers and customers to check the status of the SLAs. There are, you can check out the CloudSocket YouTube videos for the YouTube channel for more videos where you can get more information about the allocation environment, about the monitoring engine, about the cloud provider engine, and other of the components that are offered in the CloudSocket platform. So join us and visit the CloudSocket website, or this is the Twitter account, and now it's the time for thank you for attending. There's now a slot for questions and answers. If you have any question, just type it in the chat screen. I will wait some minutes before ending the webinar. Sorry, I was muted. There is a question. I am interested in the process used to bundle the applications and convert the application KPIs in predefined WS agreement offers. Okay. The process used to bundle the applications is not exactly the task of SLA engine, but I will point some hints about it. The applications are defined in at the end of the whole application, the workflow and the software components that will be deployed with the business process. It's completely defined in the BPaaS bundle, including the SLA. We have this BPaaS bundle is built in the allocation environment. So to get more information about this, you will have to check the webinar about the allocation environment. Regarding the SLA, there is a tool in this allocation environment to define the KPIs and SLOs. What is done in the regarding the SLA engine is that it converts the SLOs provided by the allocation tool into the WS agreement. This is a very simple translation from one domain to another. It's not very complicated, but you can check the source code of the WS agreement generator. You can get more details about it, because it's just a translation from the format used to express the SLOs in the allocation tool to WS agreement. Okay, I think that there are no more questions. So thank you for attending on behalf of the CloudSocket project. See you in other webinars. Okay, thank you. Goodbye.